चल छैया 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 चल छैया 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 चल छैया छैया छैया.
In this video, I will solve problem 74 regarding a distribution model by a normal distribution of mean 10 and standard deviation 2. I will use the standard trick of standardization where a normal mu sigma is equal to sigma times a normal 0, 1, which is called the standard normal, plus mu. In our case, the normal 10, 2 is twice a standard normal plus 10. So let's look at the problem. Here is the problem, 74. Given a normal distribution 10, 2, we're asked to compute a few things, including the interquartile range. Let's see how we do this. Let's start with part A. Part A is asking to compute the probability of our normal distribution 10, 2 being less than or equal to 10. We standardize, and this is the probability of 2 times the standard normal plus 10 being less than or equal to 10. The 10 goes to the side subtracting, and we have that's equals to the probability of 2 times the normal 0, 1 less than or equal to 0. Divide by 2 both sides, though really it is not needed, but anyway, the probability of a normal 0, 1 less than or equal to 0. Now, one of the properties of the normal distribution is that it's centered at the mean, in our case 0. Center, I mean half of the probability lies to the right and half of the probability lies to the left. So the part we're looking, which is the left part, will have probability 0.5, and therefore the probability of a normal 10, 2 less than or equal to 10 is 0.5. Or in general, the probability of any normal mu sigma less than or equal to mu is equal to 0.5. Consider now part B, which is asking to compute the probability of our normal 10, 2 to be between 8 and 14. So we look at first the probability of the normal 10, 2 being less than or equal to 14. That's equal to the probability of 2 times the standard normal plus 10 being less than or equal to 14. As before, we move the 10 to the other side, and we have the probability of 2 times the standard normal less than or equal than 4. We move the 2 dividing, and that's the probability of a normal 0, 1 less than or equal to 2, for which we need to go to the table. I have used a different table because the other one was not clear, but in any case you should have your table next to you. We're looking for the probability, sorry about this, the probability of a standard normal being less than or equal to 2, for which we got here and we see the 2 and then 0 here, and we get equal to 0.97725. This is equal to 0.97725. Now, what about the other part? The probability of the normal being greater than or equal to 8. Well, just think about a second. This is our normal distribution. Here is the 10, here is the 14, and here is the 8. And what we want is this area in between, which could be computed as the area to the left of 14 minus the area to the left of 8. So what we really are looking for, which is this probability, it's equal to the probability of our normal 10, 2 less than or equal to 14 minus the probability of a normal 10, 2 being less than or equal to 8. So let's compute the probability of a normal 10-2 being less than or equal to 8. A standard formula gives this is 2 times the standard normal plus 10 less than or equal to 8. Move the 10 to that side, and that's the probability of 2 times a standard normal being less than or equal to minus 2. Divide by 2, and this is the probability of the standard normal being less than or equal to minus 1. We need to go to the table with a negative value. We're looking for minus 1 this time. The probability of a normal 0, 1 being less than or equal to minus 1. So here is the minus 1, here is the 0, and here is the value. It's equal to 0.15866. Going back to our problem, that's equal to 0.15866. And the probability we're really interested on, which is the normal 10-2 lying between 8 and 14, will be equal to 0.97725 minus 0.15866. And that's equal to 0.81859. The third part is asking to compute the interquartile range. There are two ways to do this problem, so let's do it first for the normal 0, 1. We're looking for quartile 1, which is a number, so that the probability of a normal 0, 1 less than or equal to Q1 be 0.25, and the third quartile, which is the probability of a normal 0, 1 being less than or equal to Q3 equal to 0.75. First of all, by the symmetry of the distribution, here is a 0. This quantity 0.5. So if this is Q1, then by the symmetry, Q3 is going to be the negative of Q1. So we really need to compute only one of the two. Let's see, the first quartile, the probability of a normal 0, 1 less than or equal to Q1 is equal to 0.25. Look at the table, which I will not do now, but here you see this is equal to minus 0.675. By symmetry, Q3 is equal to 0.675. And for the normal 0, 1, we have that the interquartile range is equals to Q3 minus Q1, which is equal to 1.35. Now to proceed with the problem of the normal 10-2, we have two options to do it. This interquartile range of normal 10-2. Let's see, solution 1. We have the normal 10-2 is equal to 2 times the normal 0, 1 plus 10. This part here only moves things around, but it really doesn't make the normal wider or narrower. This is the part that affects the shape of the normal. So it really doesn't matter what the mean is. The interquartile range of our normal distribution 10-2 is equal to 2 times the interquartile range of the normal distribution 0, 1, which is equal to 2.7. And we could solve the problem in a different way. The second solution is consider the quartile normal 0, 1, the first quartile is equals to minus 0.675. As the normal 10-2 is 2 times a normal 0, 1 plus 10, we have the quartile corresponding to 10-2 is equals 2 times the quartile corresponding to the standard distribution plus 10, and that's equal 8.65. Similarly, quartile 3 of the normal distribution 10-2 is nothing but 2 times 0.675, which is the quartile 3 for the standard distribution, plus 10, and that's equal to 11.35. And the interquartile range of the normal distribution 10-2 is equals to 11.35 minus 8.65, which is equal to 2.70 as before. Let's finish the problem, which is asking for the third decile. The third decile of our normal distribution is the point where the probability less than or equal to D3 being 0.3. As usual, we go to the normal distribution 0, 1 and we look for its decile. Let's call it D3 star. So we're looking for the point where the normal 0, 1 less than or equal to D3 star is equal to 0.3. We go to the table, which I will not do here, but we get from here that the D3 star is equal to minus 0.525. Now we go to the standardization formula and we have our D3, which is the third decile for the normal 10.2, will be equal to 2 times the decile for the normal 0.1, what I have called above as D3 star, plus 10. That's it. 2 times minus 0.525 plus 10. And that's equals to 8.95. And this finishes the